Hi guys, again. You know that when I do a video, I usually do a video for both classes. So this time in chemistry, we'll be learning how to form ionic compounds. Now let's take a look. Ionic, just as a reminder, ionic means that it's a compound formed by a positive and a negative ion, being the positive ions cations and the negative ions are called anions. Okay, so let's just review a little bit. Cation, positive charge, and anion is an ion with negative charge. Remember, cation is the one positive because cats are always positive. Now let's take a look here. What is binary and what is polyatomic? Binary refers only to two elements. Okay, only two elements. It's a compound that is made of only two elements, a cation and an anion. So let's imagine that I have a compound made of magnesium and let's say chlorine. Okay, now when we used to do the Lewis structure for magnesium, we said that magnesium is more likely to lose electrons, therefore magnesium will act like a cation. And the number of electrons that magnesium loses is 2. As it is just 2, the charge is going to be plus 2. So my cation here is magnesium plus 2. What happens with chlorine? When you do the Lewis structure for chlorine, you have something like this. I'm gonna draw them both, okay? Magnesium. When you do the Lewis structure for magnesium, you will have magnesium in the middle and the two dots around it. Now, what happens when you have chlorine? Chlorine, for example, it's gonna be like that, Cl and 7 dots around it. 1, 2, 3, 4, 5, 6, 7. So that means that magnesium is more likely to lose electrons to lose 2 electrons, and that chlorine is more likely to gain electrons. How many electrons is going to gain chlorine to have the octet? As you can see, as it has 7 dots, it means that it needs only one electron to have accomplished the octet. So that means that chlorine is more likely to gain 1 electron. Therefore, this one, the one who loses, is going to become the cation. So this, in an anion expression, this will be written as magnesium inside brackets plus 2. This means that this is an ion. Okay, so this is magnesium plus 2. This is the ion, this is the element. Okay, one atom of magnesium has 2 electrons in the outermost level, and then as magnesium is more likely to lose those electrons, becomes a cation, so you have to write it inside brackets like this. Now, what happens with chlorine? For chlorine, it's a process similar to it, but as here, chlorine gains electrons, so you will write chlorine inside brackets, and you will write the amount of electrons that chlorine is more likely to gain. 1 electron, so that means that the charge will be -1. Now, this is what we know as the ion form of these elements, of those atoms, okay? Now, I will copy these charges here in my compound, and then I will form the compound itself, a compound made of magnesium and chlorine. The idea is that that this is balanced, okay? This should be balanced. The number of positive charges should be equal to the number of negative charges. And as you can see, the plus 2 minus 1 is not equal. If you subtract them, it's not going to give you 0. So, the idea is that we need to balance this compound. How? By doing a change in their charges. What we're going to do here is we're going to crisscross the charges. This 2 that is from magnesium, it's now going to be part of chlorine because I'm going to write it right there. So this will become, this 2 from magnesium is going to be now part of chlorine as a subscript, and this 1 for chlorine, you have to cross it too, but as it is just 1, we really don't need to write. We don't write 1 as a subscript, but in case that you want to, you're gonna write it without the symbol. As you can see, they had a positive symbol here. After it has been crossed, it loses the symbol. It's just a subscript with no symbol. Also 1, from negative 1 to positive 1. Well, not even positive, it's a neutral symbol, no symbol. But 1 is not really necessary to write it as a subscript, so we can completely ignore it, okay? And just crossing those charges that are different than 1. Now, how do we call this compound? You already know how to name binary ionic compound. This compound is known as, name of the cation first, magnesium, root of the anion, this is chloride, this is chlorine, okay? So the root for chlorine is chlor, and then we change the suffix by IDE, magnesium chloride, in Spanish, cloruro de magnesio. But what happens when we have a polyatomic compound, a polyatomic ionic compound? Okay, first of all, we need to define what binary and polyatomic are. Binary refers to only 2 elements, as we already said. But in the case that we have polyatomic compounds, that means that we are using what we know in chemistry as polyatomic ions. Let me show you a table which is in your book. As you can see here, it's called table 2, some polyatomic ions. Some, not all of them. But you'll be okay for a class if you know all of them. So you can see there are some polyatomic ions that have positive charge, like ammonium, +1, or dimercury, which is +2. But then we have some polyatomic ions that have negative charge. All this column here, all these polyatomic ions from this column here are -1 as a charge. Acetate, bromide, chloride, cyanide, dihydrogen phosphate, hydrogen carbonate or bicarbonate, hydrogen sulfate. All are the names in there. You can read them. Nitrate, nitrite, perchlorate, permanganate, hydroxide, hydrogen sulfate, etc. Those that have the charge of -2 are in the middle. And we have carbonate, chromate, dichromate, hydrogen phosphate, oxalate, peroxide, sulfate, sulfite. And then we have those that have the charge of -3, arsenate, phosphate, There's also phosphide, and there are too many more that I will give it to you. But we're gonna work with this table for now. Then we're gonna be adding more. Now, take a look here. For example, acetate. It's a polyatomic ion that is composed of 2 carbons, here and here, 3 hydrogens, right there, and 2 oxygens, OO. And the charge is, you just see the negative here, that means that is a charge of -1. In the case of sulfate, that we have here in the middle, sulfate is a polyatomic ion that is made of sulfur and 4 oxygens, and the charge is -2. The charge is written in the right side, in the upper corner from the right side. So SO4, and the charge is 2-, as you can see right there. And in the case of phosphate, for example, phosphate is made of phosphorus and 4 oxygens, and the charge is 3-. 3- is the charge. Is the number that is there as an exponent. Okay? So the subscript means how many atoms of that element is it made of. And the exponent for that same, it means that charge. So we're going to be using this table. Example. We're going to have a compound made of potassium and, let's say, sulfate. Okay, so as you can see, potassium, if you remember when we used to do Lewis structure for potassium, potassium used to be K and a dot over here. Now, we're not going to do Lewis structure every time we form a compound. We really are not going to do that because it requires a lot of work. Okay? Now, what we're going to be doing, we're going to be using the periodic table. So for potassium, you're going to take a look at the valence electrons of potassium. You will see there is 1. So that means that potassium, it's a cation with a charge of +1. Okay? And then sulfate, that is coming from the table here. Sulfate is SO4 and the charge is 2-. So what we're gonna do is we're gonna take a look at the charges, and as we did before, we're going to crisscross the charges. Potassium charge is going to be part of sulfate and sulfate's charge is going to take place or take part of potassium. Okay, so we're going to crisscross all those charges, and first of all we're going to join them as K SO4, potassium and sulfate. Now these two that is from sulfate, it's gonna be here in potassium, but not before potassium, after potassium and before sulfate. So this 2 is going to be here, and this 1 for potassium is going to be here, but 1 as a subscript we don't really consider it, so we really don't need to. And there we go, we have now potassium sulfate. Now what happens if I want to form a compound between barium and permanganate? So I'm gonna do it here. This is my first example, this is my second example. Barium and permanganate. Okay, first of all, barium, we write its symbol, it's just Ba. And permanganate, it's right here in the table. It is MnO4, and the charge is -1, okay? Or just one negative, it's the same. Now, how do I get barium's charge? You can do it with Lewis structure, as I already explained you, or you can just use your periodic table, look for barium. Barium is right here, and you can see the total of valence electrons is just +2, okay? If it was negative, it should include a negative symbol, but no, as you can see, it's positive. So that means that the charge of barium's charge is 2 plus. 2 plus and 1 minus from permanganate. Now take a look here. I'm going to do a change because the symbols are written after the charge, like that, not the way I had it before. So the idea is that now you have to crisscross the charges, okay? So you will have barium next to permanganate. Now, this one from permanganate is going to be here in barium, okay? And this 2 from barium is going to be here after the 4 of oxygen. Oh, Jesus Lord. It was just 2, not 4. Okay, so this 2 that is coming from barium is going to be there. Now, what's going to happen? As you can see, here we have 4 and 2 together. So, we cannot have this in chemistry, nor the subscript of 1, we can erase it, we can skip it, we really don't need to because it's implicit. But here, this cannot occur, this 2 from here cannot be below the 4. So what's going to happen? You have to add parentheses, and this should look more like barium alone with the charge of 1 as a subscript, and then MnO4 parentheses 2. Not that low, okay? This 2 shouldn't be that low. But what does the parentheses mean? Like in math. Parentheses in math, for example, you have in math x times 2x plus 3. And I say, okay, perform the multiplication. So what you do in math is you apply distributive property and you multiply x times 2x, 2x squared, x times 3 plus 3x. And this is the multiplication, okay? Now, in chemistry, what is going to happen is, if I ask you, okay guys, how many manganese I have over there, how many oxygens I have over there, so what you have to do is you have to consider that you have parentheses. These parentheses represent basically a multiplication of what? Of the 2 that is outside the parentheses and everything that is inside. So if I ask you, I want to know how many atoms of barium, manganese, and oxygen are there in barium permanganate. Okay, this is what you have. So what tells you about the number of atoms is the subscript. So barium, as you can see here, doesn't have subscript, so that means that it has just one barium. Now manganese has just invisible 1 as a subscript too, but it's this manganese, as it is inside a parenthesis, and this parenthesis is multiplied times 2, you will do what you did in math, distributive property. So these 2 will multiply manganese, but also will multiply oxygen. So instead of having 1 manganese, you will have now 2 manganese. And for oxygen, you had 4, but this 4 is being multiplied times these 2 outside of parentheses, so you're going to have 8 oxygens. So this compound actually is not just made of 1 barium, 1 manganese, and 4 oxygens. No, it is made of 1 barium, 2 manganese, and 8 oxygen, because this 2 that is coming from barium, remember this 2 is coming from barium right here. So this 2 that is coming from barium is going to take like an active role in the compound, and is going to multiply everything that is in the parentheses. But this parenthesis will include just the polyatomic ion. So every time this happens, okay, every time this happens, you have to add parentheses. Here I didn't do it. Why? Because if I add parentheses here, and this one that is coming from potassium, I place it here, it's not, sorry, you were not saying anything. So what if I place parentheses here, as I was saying, and this one from potassium is coming here. So what's gonna happen is that you will have K2 SO4 1. And if I ask you, okay, tell me the number of atoms in this compound. For potassium, as you can see, 2. For sulfur, it's going to be 1 times 1, 1. And oxygen, 4 times 1, 4. So it's not going to affect you at all if you use parentheses here, because the charge that you crossed is just 1. So you really don't need to. But in case that you have a charge that is being crossed different than 1, like we did here in barium, yes, it affects how the 2 outside of parentheses multiplies everything inside of parentheses, and that's how everything is affected by it. So guys, this is it. Thank you for paying attention. Thank you for watching all the video. I know you don't watch it at all, but those who really do it, thank you. I hope you have understood. Any doubt, please send me a message. Bye bye.